and to find the information. Oh, you order it over. It means you study. The first part of theoretical mechanics is static. It's okay. So that's stress and strain. At first, we have to know the objective of this subject.
Why is starting with chapter 7?
What?
Why is starting with chapter 7?
Chapter 7. Where? PPT is bad. It's bad.
Yeah, but why is chapter 1, 2, 3, 4, 5, 6?
No. Chapter 1, chapter 2, chapter 3 is statics. You studied in the last semester. It's in theoretical mechanics. It's in theoretical mechanics. Let's show you. It is chapter 1, chapter 2, chapter 3. In the textbook, there is a textbook. There are two parts. The first part is statistics. The second part is mechanics of materials. Last semester, we learned statistics in theoretical mechanics.
The theoretic mechanics.
Theoretical mechanics. You studied it last.
Yeah,
semester.
theoretic.
Yeah. Statistics is the chapter 1, chapter 2, chapter 3 to chapter 6. So I begin with chapter 7. Chapter 7 is mechanics of materials. Understand?
Yeah.
After we know statistics, we can study mechanics of materials. If you know the loading of a member, when you want to design a member, suppose the beam is a member. Yes, the beam is a beam. It's also a beam. A beam is a member. If you know the loading acting on the member, how to know the loading acting on the member? We have to find it from statistics. You learned it in the last semester. after you know the loading acting on the beam, we have to find the stress disturbing in the beam. Yeah, it's you learned it in the last semester. You didn't know, but the schedule is. It means last semester you studied the statistics.
Last year, during the pandemic time, there is no class semester. We had only 4 class. Yeah, only 4 class. Right. Just we have finished last week. That's why we didn't learn previous semester. That's why we
You means you didn't know statistics.
Yeah, right.
You didn't know statistics. But my job is going to teach you mechanics materials.
Yeah, understand. Last semester there is no.
How to deal with it?
Study 4 days, only 4 days or 6 chapters. You didn't understand.
You didn't understand the statistics. In this class, I have to introduce some basic knowledge of statistics.
Okay.
For mechanics of materials, after you know the loading acting on the member, listen to me. In mechanics of materials, we can find the distribution of the stress in a member. The distribution of the stress in a member. After this point, after you can find it, you can determine the member is safety or fracture. After you find it, we can design the size of a member. Member is member. Suppose a beam, a column, the floor. We call this kind of things of beams in a structure. A structure is composed by members. Understand? The first topic is to find the distribution of stress in a member. The second topic is to find the deformation of a member. For example, after loading acting on the beam will be bent. It's not, it will be bent when loading is acting on the beam. In mechanical materials, we will find the deformation of the beam. Understand? For example, if the deformation is too large, for example, if the floor is go down very hard, too much, it go down, we are fear. It's not safety. It's not. So we have to find the deformation of a member. We know how to find the stress in a member, how to find the deformation of a member. We know how to design it. Design it means determine the size of a member. Understand?
Yes.
This is the objective of this subject. But if you don't know statics, you can't understand mechanics of materials. So, if you don't know statics, I have to introduce the basic knowledge when I'm teaching this subject. Okay? The first chapter is stress and strain. Stress is a new conception for you. Stress is the local force happened in a point in the member. Strain is a local deformation of a point in a member. It is the most important conception in this subject. Understand? The objectives of this chapter is to use the method of selection to determine internal loading in a member. For example, is a pin. Suppose this pin is not. It represent the pin. When the force acting on it, we can find the reactions acting on it. How much? How much is the force acting on point A and the force acting at point B? We know how to find it in statics. After you find the loading, the forces acting on the pin, we have to find the force happening in the pin. The internal force, the internal loading, or the internal force is the force acting. Suppose we count the pin. Imagine. When you imagine counting the pin, separated into two parts. The left side, the left part, will acting a force on the right part. This force, we call it internal force. The internal force is the force acting in the member. One part exert a force on the other part. The force is the internal force. How to find the internal force, internal loading? We use the method of section. The method of section is important. The method is important. The other purpose is to introduce the concept of normal stress and shear stress. Normal stress is different from shear stress. supporter. It's normal stress. We denoted by sigma. We denote the normal stress by sigma. The outcome, the result of the normal stress is to elongate the member of the normal stress acting on the member. It will be longer than its original long. Yes, no, it will be longer. Shear stress is in this direction. So, it means normal stress is perpendicular to the cross section. Shear stress is parallel to the cross section. Parallel to the cross section. The deformation, when the shear stress acting on the member, it will be deformation in this way. As is the deformation. So, it's different. There are two kinds of stress. There are two kinds of stress. But up to now, we don't know what is stress, what is deformation, what is strain. We don't know. Yes or no? Because I didn't introduce it now. Up to now, I didn't introduce it to define and to determine normal and shear stress. And first,
there is normal and shear stress, and there is normal and shear strain.
yeah, there are normal stress.
And
Also, there are normal strain. It's difficult. Mechanics is difficult. And first, actually introduce how to find the internal loading. How to find the internal loading. Okay? Because we don't know statics, I have to introduce the basic knowledge. Okay? This belongs statics. Okay? Right. The first one is suppose is a pin. A force F is 10 Newton acting on it. How to find the reactions and the two ends? How to find it? You don't know. Do you know? Suppose it's a it's a family. Suppose it's point A, it's point B. Can you find it? Don't know. All of you don't know how to find it.
the reaction.
You don't know. I suppose you know how to find it. Otherwise, you can't understand the theoretical of materials. Last semester, who teach you the theoretical mechanics? Last week.
Yeah, we studied last 4 days.
Last week, in this semester. They teach you theoretical mechanics in Chinese or in English? English.
Only loudly, there is 17 chapter, only 4 class.
Only 4 classes.
Yeah.
We learned 14 chapters in four classes.
You can try.
Let me try. So,
Assume it.
I need to try.
I will assume it. I have to tell you how to find this kind of how to solve this kind of problems. It means when you want to design a member, at first we have to know the loading and the exerting on the member. At first we have to know the loading. Yes or not? Statics can find the loading. At first, we have to draw the frequency diagram. Do you know frequency diagram?
Yes.
You know. Do you know how to draw it? Yeah, try it. Frequency diagram.
Let's suppose you take A as a fixed point.
Okay.
Then
What kind of support is it?
kind of support.
Can you don't know? Maybe I at first we have to draw the frequency diagram. Yes, sir. What kind of support is a hinge support? It's a hinge support. It's a roller hinge. Understand? It's a roller. It means at first we draw the figure of the pin, remove all the surroundings. It means it's a free body. At first, when you draw a free body diagram, at first remove all the surroundings, just do the member itself. Understand? It means and remove the support or removed. Then because it's a hinge support. For a hinge support, there are two actions. One F A X. The other one is F A Y. It's a roller. It's a roller. Roller is FB. It's a F. So, it's the frequency diagram. It's the frequency diagram. After you find the frequency diagram, we can solve the problem. It's a plane force system. It means all the forces are in the same plane. We can get three independent equilibrium equations. Understand
Yeah.
what I said? So the first one is sigma Fx equal 0. It is a equilibrium condition.
Yes.
It means if the pin is balanced, the summation of all the forces in horizontal must be 0. So we can find that F(A)x equal 0. Yes or no? The second
Summation of Y.
summation moment of the point A must be also 0. Yes or no?
Yes.
We can find that FB times 15 meters. Yes or no? Minus 10 minus 10 Newton 10 meters must be 0. find A. Do you know why? Because force Fax pass through point A.
It's showing still open study.
What?
Yeah, it's minus still going.
Minus, yeah, minus or minus, yes or no? Because the moment of point FB is anti-clockwise. For this force is clockwise. We said anti-clockwise is positive, clockwise is negative. So it's negative, it's positive. From this equation, we can find FB is yes or no? This is the second equilibrium condition. Then we can get the third equation. The third equation. I write it. The third one is sigma Fy equals 0. It means Fay plus Fb minus 10 is 0. So we can find Fay equal 10 minus 100 over 15. In this way, we find the reactions. Then you know, it is statics. So I have to introduce the basic knowledge of statics. So I can limit. Okay, are you ready? Okay. No. You didn't copy that. Okay. So, because statics is to find the forces. How to find the forces? I have to introduce the method. It's not my job. Because you don't know, I have to introduce it. It means I repeat it. It's the first the procedure, how to find the forces act on member. The first one is F BD free body diagram. We have to find the free body diagram. How to find the free body diagram is the first important point in statistics. And first, free body diagram. One is draw the member. B, the second step is to action. applied logic. Applied logic. How to draw it? How just to copy it. So the third step is to draw the reactions. How to draw the reactions? According to the kind of support. Determined by the kind of support. Do you know it?
No.
No. So it's a challenge for me to teach you mechanics techniques. It's a challenge because your basis is very poor.
Yes.
Actually, how about if you say that those chapters like chapter 1 to 6?
Chapter 1,
The same as
from chapter 1 to chapter 6 is starting.
the one that we get to
The other teacher,
the one that we get from the teacher. This teacher. Which one?
Love.
uh,
They didn't give us this.
That's what I was saying. It depends on no.
you study the theoretical mechanisms.
I'm requesting for chapter
Don't know.
You know, here is chapter 1 until 6 and 7 from chapter 6. So I was thinking give that one for the last one.
Is it
Then we
information?
can start the one that is second, then we can get
Old
the
class.
Only 4 classes.
This one is
Only 4
What are
classes.
those for each chapters? Which one is for each chapter?
It's a, we have no chance but we have no chance but to continue it. If we don't know how to find the forces, I have to introduce it.
The problem is theory of messages. We are supposed to study it in whole semester, but we only.
I know. She told me.
Yeah, but you were given 14 chapters. But then also that one is just one chapter, right?
love.
And you will not only need chapter 2. Maybe we will
I know.
also actually from chapter 1 to chapter 2 from that. Chapter 1. No, I'm asking about the one that we see. That one is 14
Can you help me?
chapters. And then for you, it's chapter 1 to chapter 2. And then you started with 7. And so which one they are saying? Yeah, one. That's one. Yeah.
Is it possible to learn those subjects
Well, I haven't got enough time. So
And then the thing is that even the time we have to learn that chapters, it's really so small. Imagine 14 chapters just in 4 class.
Yeah.
14 chapters. One day will be, it's just like we are reading the story. We are not learning anything. So it's really hard for us to understand what it's really hard.
yes, I know
The
it.
chapters, the content is a lot, they still have a lot of things to do.
We introduce the basic knowledge here. Okay. All my teaching.
This is very important for us.
Yeah, it's very important for you. I know.
But
So
actually when
you just follow me, okay?
Alright.
You just follow me.
Also, alright.
I will help you how to know mechanics of materials. In the meantime, I will introduce the basic knowledge of statics. Okay. It's statics. The first important point is to get the report diagram. It's the procedure ABC. ABC is the procedure how to get the report diagram. Okay? I will give you some example. Okay? Reaction. The difficult point is the actions. How to do the reactions. We introduced some kinds of support. It is a frictionless surface. Frictionless surface. How to do the force? How to do the reactions? By this kind of support. It is copied up. This is a reaction. Is a reaction. Is the fractionless surface. Fractionless surface. It's a loop. It's a loop. It's a ball. The surface, the force. The force of the loop exerting on the ball is along the loop. It is aware. It is aware from the body. It is aware. It is towards the body. You have to remember it. This two kinds of. This is the first kind of support. For loop, a cable. This is the second supporter. Yes, cable supporter. The third one, I can limit it. You copy it. Do you copy?
Yes.
Copy it. Copy it now. Copy it. It's a loop. It's a loop. Copy it. It's away. The force is away from the body along the loop or cable. Understand? Okay, finish.
Yes.
The third one is a fixed hinge. What is it? Hinge. Hinge supporter. We call it hinge supporter or pin supporter. This kind of support, we call it pin support or hinge support. This kind of support, we call it roller. For the pin supporter, the reactions is two forces. they are perpendicular each other. It's not so. So the reactions will draw it in this way.
That's the question. Physically, how can you know that this is a pin or this is a roller?
Yeah.
How can you see it? Or you can imagine that cell is a roller, this.
Because it's different. The figure is different.
Oh, it's the.
Yeah, it's different. Yeah.
Oh.
The figure is like this. The figure is like this. That's different. For a roller, suppose this is a pin. It's we put it on the pin. The pin can move horizontally. Yes or no? But can move down. Why? Because the force, the table exerts the force of vertically on the pin.
Yeah.
So there are just one force. There is just one force. But for pin is what is the pin? For pin, when hold fixed data, it can't move horizontally
Yeah.
and vertically. Can't. Two direction move.
Yes.
We can it can't. So there are two forces, and it's a difference. Copy it.
Yeah, yeah.
Okay.
Yes.
The last one is we call it fixed end. We call it fixed end. Fixed end it means suppose we hold the rod straight. It can't move vertically, can't move horizontally, it can't rotate. Yes or no? It can't rotate. So there are three reactions. There are three actions. It is in this way, eh? So force and moment. And there are three reactions. Understand? Yes, sir. Copy it. It's a different question. Not that different. Fix. And copy it.
Yes.
Okay. Last one is suppose two rods are connected by a hinge. Is a hinge. Two rods are connected by a hinge. How to draw the frequent diagram of this one? How to suppose it's A, B, C. How to draw the actions of BC at the point B? We know. Suppose two rods is connected by a hinge. If this one is fixed, the point at the point of this one of this rod and the point B can't move horizontally or vertically. It can't move. Yes, not so. The member will exert two forces on the member. So it's also two forces. So there are two forces. Understand?
How do we call it? The name.
It's B said. We call it FB X. It's FB Y. For force we have to learn it.
It's a foot. How do we call it?
What?
Hinge.
Hinge connection. If you draw the flip of the diagram of AB, yes, at point B, member AB exert FBX, FBY on PC. At the same time, member BC will exert force on AB. It's action and reaction. So there is a
Newton,
F B X prime F B Y prime. Yes or no? F B X and F B X prime are equal and opposite in direction, are equal in magnitude. Understand? It's physics.
Yes.
Yes.
Like third law of Newton. Action and reaction is equal.
Yeah. Are equal in magnitude,
And
opposite in direction.
yes.
So we have to know that. Okay. We have to know a force is the internal force of. Copy it.
Yeah.
Finish. Okay. Is it F A B C? Yes, sir. Suppose we choose figure. I can do this.我刚才帮生气。我想，is too small.
Yeah, right.
I don't even know how to use this device. I want to turn off it.
Wow.
Why? Wait. Why can't I turn off it? I want to turn off it. No, just turn off the projector. No, is it? Oh, okay. Okay. suppose there is an example. There is an example. There is an example. F1, F2, A, B, C. Because you don't know statics, I have to make up it. Okay? At first step, when we draw the figure, the flip diagram of FP is now FP. Look at the procedure. I write it on the blackboard. You didn't copy the procedure. ABC, yeah. Flip diagram A to the member. It means I to the member. Yes or no? The first, the P is draw the applied loader. Applied loader, we just copy it. F1 is applied loader. Reactions according to the kinds of support to the reactions. Okay? What kind of support it is? In support. How to do the reaction? To force, perpendicular forces. F-A-X, F-A-Y. Yes, now. How to do the reaction at this point? Because it's a pin connection. Yeah. You're clever. F-B-Y, F-B-X. Each is a flip diagram. Each is a flip diagram of A. Understand? The first one is draw the member. Remove all the surroundings. Yes, no? Copy the applied loader. How to draw the flip diagram and the point? Can you draw it? You are doing some mistake. Go back. So you made a mistake because its action, it will be reaction. So when the force is pointing to the left, it will point to the right. It's downward, it must be upward. Action, the reaction. Oh, did you copy that? Your copy is wrong. You copy, man. Oh, it's hot. Yeah, your copy is right. Your copy is wrong. Yeah. When the force is to the left, it must be to the left. Why? I ask your copy, man. Introduce the you didn't copy it. You didn't copy, man. It's just an example. You didn't copy it. Yeah, you have to copy it. Why is that? That was just one person. I don't know what is that. Which one is that? So it's a big problem. when I ask you copy it, it means in the future I will use it. Yours, copy it. Yes, oh. Well, action, reaction, you know, they are opposite in direction. Yes or no? But when you draw it, you make a mistake. Yes sir. So it's f b x prime is f b y prime. And what kind of support it is? It's a ruler. It's a ruler. How to draw the reaction of a ruler? Can you do it? Just one force. Yes or no? F(c)(y). So it's okay. Then, if I ask you to draw the free-body diagram of the entire structure, at first we draw the entire structure, but remove all the surroundings. Understand?
Yeah.
Here is a pin support. The force is the force. F-A-X, F-A-Y, is F-C-Y. But at this time, the forces in point B, it means F-B-Y, F-B-X are internal force.
What?
F-B-Y, F-B-X are internal force. Internal force. When you draw free-body diagram, we don't draw internal force. So we have to write this kind of don't draw internal force. Understand? Read the sentence. Don't draw internal force.
F-B-Y and F-B-X are internal forces.
Yeah, it means what is internal force? What is external force? Yes, sir. What is the internal force? What is the external force? You don't know. If the force, if the body for force, there are a body exerted. Yes or no? If the body is, if you don't consider the body, the force is a external force. If the body is in your analysis, if you are consider the body, the force is a internal force. For example, when we draw the free-body diagram of AB, we just consider AB. Yes or no? We just consider AB. We don't consider BC. The force is exerted by BC because we don't consider BC. So it's a external force. Is also an external force. So we just draw external force. when we draw the flipped diagram
Yeah.
of the entire structure,
We don't draw the
BC, we consider BC,
Mm.
we include BC,
Yeah.
it's not.
Yes.
So, because the force is exerted by BC, at this time, FBX, FB1 are internal force.
That's
Understand?
why we don't draw the
So we don't draw internal force. So in this case, we don't draw FBX and B1. In this case, we must draw FBX and FB1. Yes or no?
Yes.
Got it? If you know this kind of things, it's enough. It's enough. I will introduce a little more examples. You needn't copy it, okay? You needn't copy it. A, B, C, F. Can you use the flip diagram of A, B, and B, C? You can, okay? You can A, B, B, C. Okay? Can do the blackboard. It's to how to turn off air conditioning. You don't know how that. You're not how that. It's cold. It's cold. And hot. In other location, it's your copy of I ask you to copy it. In the future, we have to solve problem according to the record, but it's just some exercises. You do, yeah, on other page to do this kind of things, okay?
Oh, I don't need to do this.
Yeah, you do here. Yeah, some things I ask you to copy it. You copy in the same place. Okay? Yeah, it's just an example. You didn't write it in the same place.
But last year, maybe I need to like do the last one.
This is for the stream and the streams.
It's static. Static. This, you said, you didn't finish that. You said,
You see.
you said, how to draw the flip diagram.
This is
BC. Yes, you're clever. Yes. Why is A? Okay. So, say something, please. Say that, please. Let's pay attention to the name. Why is X?
No, why?
X, we mean horizontal. Yes, sir.
Why?
Why is X? How
It's why?
Why? Yeah, it must be why. You are good. It's pointing to the left. It's pointing to the right. It's FB Edison. Why is it pointing to A? Why is A? It's a simple. It's B. It's a B. That's not. It's B. Understand? Understand?
Yes.
Yes. No. Yes. It's pointing to the left. It's pointing to the right. It's okay. Yes, sir. It's pointing. It's upward. It's also upward. It's missing. It must be downward. Action and reaction.
Yes.
Yes, sir.
How?
Action and reaction.
Opposite.
Opposite.
Direction.
Opposite in direction. Understand? Don't understand. If I compress the table will be exert force on my hand upward. And downward, he is upward.
But the force there is in the middle. Why is it on the point?
It's just assumption. Assume.
Imagine.
We assume the direction of the force.
Yeah.
Actually, we don't know the direction of the force. After you find the force, we know the direction. Understand?
So what if?
And then you lost the grand load. You lost it. Why? Yes, not.
One is this load is an external force, right? Zero.
For this member, it is the force. For this member, it is external force. But for in the entire structure, they are internal force. Suppose you choose the free diagram of the internal structure. The whole structure.
The question was about this load, this force is external force.
Yeah, it's a applied load. It's applied load. Applied load, we just copy it. We just copy. Understand? Who can draw the frame diagram of the entire structure? Who can draw? Who can draw? You can try. Let's try it. It's important. It's important. create rotor.
B and C.
Copy. Operator just copy it. What is the meaning of the line, the vertical line? What is the meaning? There is no this kind of line. What is the meaning? Yeah, now. What kind of supporter at point B, at point A? What kind of supporter? Fixed supporter. Yes. Now it's right. It's excellent. Yeah. No, X, no. Go down. Yeah, no X. Now it's right. It means at first we have to know how to draw the free body diagram. This is the first step to solve static problems. We have to know how to find the forces. After you can find the forces, you can study theoretical mechanics of materials. Otherwise, you can't understand my subject. Remember this kind of things.
Yeah.
You can lost your copy. You can lost your copy. How to draw free body diagram? If you don't know how to draw free body diagram, I will ask you to open your notebook. Turn to this kind of place. Understand? After some practice, after you do a lot of exercises, you can know how to do free body diagram. Okay? This is the first important things. Okay. For statics, how to find the forces, we also have a procedure. The first step is to find free body. Consider a member. Consider a member. All members. Consider a member. All members. All members. Then draw free body diagram. The last step is data equations. Data equations. This is the procedure to find the loadings on member. Copy it on your notebook. For example, F E F1 F2 is 10 Newton. F1 is 20 Newton. 2 meter. 2 meter. How to find the reactions? How to find the reactions? At first, consider consider AB as law. Step 2. Give the flip of the diagram. Can you do the flip of the diagram? Try. Oh, where is your copy? The notebook is empty. And read a lot of things on the blackboard, but you haven't. So I guess you can't do the practical. Try. I guess you can't do it the right way. Come here. To flip the diagram. What is the flip of the diagram? If you don't know how to do the flip of diagram, you can ask someone to help you. Okay? You ask someone to help you.
No, you.
Okay, ask someone.
Yes.
If you ask someone help you, he must come here. Otherwise, I will criticize you. Come here. Because you don't know. If all of you don't know how to flip the diagram, I can continue. Yes or no? You know. Yeah. It's just an example. You didn't copy it. Okay, you didn't. I asked them to solve it, okay?
Reaction, action.
Look at your hand, your cup. Look at your notebook. Where is the schedule? Check your figure. A, B, C. Check your. A, B, C. Yeah. It's A, B, C now. Draw the member. A black note. Where is your black note? There is no black note. A. Step 1 is draw the figure. Step 2, draw a black note. You don't know. You didn't draw the black note. A black note, a black note, you have to draw the force. Just copy it. A black note. How to draw a black note? Copy it from the original problem. Understand? Go back, go back. So, it's a challenge because of the some days, maybe after today's class, some of you can do flip diagram, some of you can't. What can I do to do with it? Is a flip diagram. Understand?
Yes, sir.
Yes, sir.
Then the last step is to equation. All the things we just get see sigma fx equals 0, sigma fy equals 0, sigma ma equals 0. Sigma fx equals 0. What is the meaning? It means if the member is balanced, all the horizontal forces, or the summation of the horizontal forces, must be 0. What is the meaning of this? It means the summation of the vertical forces must be 0. What is the meaning of this equation? It means all the moment, all the forces, all the moment of the forces about point A must be 0. We can replace point A by point B. Understand?
Yes.
It's totally up to you. You can select it point A. You can also change it point B, or change it C D. It's C D. All points are right, and but you just can get 3 equations. We can't get the 4th equation. There are just 3 independent equations. Understand?
Yeah.
Okay. How to do it? How to do it? It's the triple diagram. You know, I know you have. But is there any others who can do the equation? No. What is the meaning? What's the meaning? It means the summation of all the forces in horizontal must be 0. In the figure, there are just one force in the horizontal. Yes or not?
Yes.
So, is 0. It means from the equilibrium condition, we find if A is 0. Yes or not? If Fy is all the forces are all the vertical forces, it's downward. Downward is negative. Charge is 10. Is 20. Must be 0. Understand? MA, suppose we take the point, the moment of A. Is point A, yes or no? For the force is clockwise. Clockwise is negative. Minus is 10 hence 2 minus 20 minus 4 is plus Fy hence 6 is 0. Because Fax passes through point A, so is Fax times 0. Fax point A passes through point A, so Fax times 0. So in the equation, there is no Fx and Fay. Understand?
Yes.
Okay. So can you find the result?
Yes, we can.
You can.
Yes.
Yes. So in this way we can find it. We can resolve it.
Can I explain Fy?
Explain
Fy.
Explain Fy. Sigma Fy. It is a summation Fy. Yes or not? The total force is outward. We assume outward is a positive. downward is negative, so it's positive, positive, negative, negative. That's why the summation of all the vertical forces must be 0. Understand?
Yes.
What is?
What is
I mean, like, you see, the sum of
the sum of M?
M is what is.
M is the moment.
Why not system? Because distance.
What is the moment?
There's no, I think there's no moment is distance.
The distance is the number.
Yeah.
The distance is 2.
It's not distance.
For this force, the distance is 2 meters. Huh? Okay. Is there any other question? No question. If you have no question, I have to introduce another example. Okay. I change it. I change it. Suppose the force change the direction. Suppose it's 30 degree. 30 degree. How to solve it? Yeah, I think you know it. But is there another student? Just one student now. Do you know? At first, we have to resolve the oblique forces into its 2 components. Understand? The one is 10 sin 30. Yes or no? The other one is 10 cosine 30. Yes or no? So the equation will be minus 10 cosine 30. So it's sin 30. Yes or no? So it's sin 30. Understand?
Yeah.
Understand? Don't you know? Maybe after class you have to help others. Otherwise, the class can't go. Okay? Yes, it's a challenge. Do you want another example? Okay? Another example. You don't copy this one. You didn't copy. You didn't copy. You didn't. Oh, what is the same person? For a triangle, that's not is theta. Suppose the length of the oblique side is L. The length of this is L. Cosine theta, this is L. Sin theta is mathematical. That's that. Sorry, you can is theta, yes or no? So this one is sin theta, sin 30. It's cosine theta, cosine theta. Just need to know it is enough. We just need some simple mathematics. Okay? Complicated the mathematics we need. What time you need? 10 is over. So today, I didn't introduce mechanical materials. I introduced some basic knowledge of statistics. It's good, but you have to recall the copy of your notebook. You have to understand it. Next class, I will test you. I have to identify if you know how to draw Freeport diagram, how to solve this simple static problems. Okay? I give you a assignment, homework. Okay? You have to show me before class. Tomorrow we have mechanical materials tomorrow morning. Homework are find the reactions at the point A. Homework. Before class, you have show me your work, your homework. If someone don't finish his homework, I will give him low score. Understand? Yes. Maybe you can pass the final examination. Every class, I will give you one problem. It's easier. Understand? If you don't know, maybe you can help others. Okay? If you don't know how to solve the problem, I have to repeat it again and again and again.
It looks like different. Different.
There is a force. The length is 1 meter. The length is 3 meter. The force is horizontal. Understand? Do you have class at the 10 o'clock? What subject? Engineering material. Okay. So I have a question. Otherwise, I can teach you. Continue.